forgot to turn it on. At least the answers are sitting there. All right, next one. Number 20. In triangle ABC, A and B are complementary, where the cosine of A is 0.5. What's the measure in degrees of angle B? Now, complementary. We probably need to have some idea what complementary means. What does it mean to be complementary? If A and B are complementary, what does that mean? Not similar. Remember, we have complementary, supplementary. So complementary are two angles that add up to 90. So angle A and angle B, if I add them together, I'm going to get 90. That's what complementary means. Complementary adds 90. Then it says something about a trig function. Cosine is a trig function. And if it says something about a trig function, what type of triangle are we going to be using? What type of a triangle do we use trig functions on? A right triangle. So I'm going to draw a right triangle. And they've told us that these two angles are the A and the B. So this must be C. Now, the cosine of A is 0.5. So A is up here. Remember, it's the cosine of the degree equals whatever it gives us. I don't know the degree. That's what I'm trying to figure out. So if I'm trying to solve for the degree of A, what do we have to press on the calculator? Does anybody remember what we had to press on the calculator to get the degree? If I'm solving for the degree using a cosine, sine, tangent, remember you got to do the inverse, and that'll give you the degree. So if you're trying to solve for the degree, you have to use the inverse. I know it's been a while since we've done the trig stuff, but if you're trying to solve for degree, you use the inverse button. So if you use the inverse button, you type it in, you end up getting 60 degrees. So 60 is here. We already knew this was 90. We already talked about that. Now the question wants to know what's angle B. Well, I've got everything set up to get angle B. So angle B must be how big? Well, we already know angle A plus angle B was 90 degrees because that's the complementary. So angle A is 60, so angle B must be 30. So I get 30 degrees. That's what I was saying yesterday. Trig functions. You're definitely going to have some trig functions. There will be 3 or 4 questions that use trig functions somehow, some way. That is one example of a trig function question. Next one. We got a chart. Notice my chart has 5 words and only 4 blank spots. So one of these words must not belong. So can we kind of figure out which one doesn't fit? Which one of these 5 words doesn't seem to even fit? Which one can't go in that chart?
Kite.
Kite. Kite's the one that doesn't belong. So we're going to get rid of kite. Because everything up there is a type of a parallelogram. So we have polygon, quadrilateral. All of these are types of parallelograms. So parallelogram must come next. So I'm getting more and more specific. Now, underneath, there's 2 blank spots. Doesn't matter which one's on which side. It'll count correct either way. But what's going to go in the two blank spots for the buck? What are my next two words? I'm good with rectangle. I'm good with rectangle. Remember, parallelogram, that's kind of the shape you think of when you think of parallelogram. Rectangle is a type of parallelogram with 90-degree angles. So this one has equal angles. I'm looking for a parallelogram with equal sides. Equal angles, equal sides. So what's the parallelogram that has equal sides? Rhombus. So this one should be rhombus. And like I said, these two words can be switched. So if I have all 90-degree angles and all equal sides, 6 must be square. Square is the most specific. If you remember when we did quadrilaterals, there wasn't a whole lot we could do with a square because it was always 90 degrees. Once I knew the side, I knew all the sides. If I drew the diagonals in, I knew every little piece was equal. I had 45, 45 all the way around. There wasn't much I could do with a square. So that's our chart. Questions on the chart? $21. 21 is one of those cases that I haven't done constructions. Because we had to go remote for a little while, I didn't get as much done because of remote. We never got to constructions. But even if there's something we didn't get to, and part of the reason I picked constructions, one of the things we didn't get to, is sometimes you can kind of draw it and think it through. Tricia wants to create a perpendicular bisector of line segment AB. So I have line segment AB. So draw yourself a line segment. A, B. She places her compass on point A. So she's going to place her compass here and open it to B. So basically I could draw a great big circle where A is the center and it goes through B. And it says she makes arcs above and below. So that's kind of what we're looking at right now. Now, let's look at our choices. Because that's what they told us that we've done so far. Connect the two arcs using a straight edge. When it says to connect the two arcs, I don't really know even where I would connect this because it's an arc. It's not like I've got a point there. I don't have a point here. It's just an arc. So I can't really do that because I don't even know where I would connect. So that one doesn't make sense. Connect each arc. Well, again, I can't very well connect an arc if I don't have a point on the arc. So I can't very well do that. So that one doesn't make sense. Place the compass on the approximate midpoint and draw intersecting arcs. So that's saying if I put on the midpoint, I can draw a circle there, which doesn't seem to make sense with what I'm even drawing. So that one doesn't really make sense either. But this one does make sense. Because this one, it says, she places her compass on point A and draws some arcs. She places her compass on point B and does the exact same steps. So by doing that and going here, I end up with arcs that now have some place I can connect. And if I were to connect them like this, I would have a perpendicular bisector. So it's this guy. Now, like I said, we didn't do constructions. There's usually only maybe 2 construction questions. But if they do give you a construction question, kind of think through the steps they've already given you. And then usually we'll say, what's the next step? Kind of think what's the most logical thing to do next. Next question. 60. We're going to look at at the picture for a second. Then I'll make it smaller so we can actually look at the choices. So the picture. Now, I've got two triangles. Triangle ABC is similar to triangle PQR. So we know these two triangles are similar. So whatever this is, if I just enlarge it, I'm going to get this one. They are similar. We know that. Then it says triangle ABC has a cosine C that equals 0.92. I mean, I could figure out what it is, but I don't even really need to. But because they give us the cosine, because they tell us this, would I be able to figure out how big x is? Could I figure that out? Hello? If they tell us the cosine of C, would I be able to figure out how big this segment is, the bottom of this triangle is? Could I solve it? I could solve it. I could figure out how big x is. So right now we have, because these are similar, we have 20 over, well, I don't want to do that. That'll confuse you. But this one I know. I know that. Or at least I can find it. I know. Now, Dwayne claims that the value of x can be determined, which we just said. We can figure out the value of x. But the information provided isn't sufficient enough to find the value of y. So if I know two of these two sides, if I know them, can I figure out the value of y? Yeah, I can do that because once you know these two, I can set up a proportion. Remember, similar triangles are always proportional. So I can set up a proportion where I said these two things equal to these two things, and I can figure out what the y is. So him saying that he doesn't have enough information is wrong, because we do have enough information. We do. Now let me make this smaller so we can look at choices. Okay, so here's my choices. We already said that we can find it. Well, this one says he was correct, that he couldn't find it. Well, we already said we could. This one says he was correct, but we already said we could find it. So it can't be this one. So those two are gone, because we know we can find out that number. We know we can do that. Now we got to figure out what makes one of these two wrong. Notice, 20 over x, x over 20, y over 45, 45 over y. That's the difference between these two statements. And it says cosine. Cosine. What's the ratio for cosine? It's on your reference paper. That's why I gave you a reference paper. Adjacent over hypotenuse. So if I'm going from C, remember here's your hypotenuse, walk across the triangle to opposite, next door is adjacent. Adjacent, x, hypotenuse, 20. So I have to use x over 20, because that's what cosine is. Well, as soon as I know that I had to be x over 20, because that's what cosine is, C no longer works either, because it said 20 over x. So it must be D. So this is another example of how they might use the trig functions. So if you have trig functions, you're probably going to have to figure out those ratios. You've got the ratios on your reference paper. Use your reference paper. Now, we have not a lot of time, but we do have a little bit of time. So what I want you to do is start looking through the next page. Start looking through the next page. So that's 28. 28 is a probability question. 30, you're filling in the blank spots. Down here is what can go in the blank spots, so it's another drop-down sentence. This one is kind of a multiple transformation. It says you rotate, you dilate, you translate. So you do all sorts of stuff on this thing. 41, you're looking at a cylinder. So you're probably going to need your formulas for a cylinder. So start looking at it. Tomorrow I'll give you a little bit more time, and then we'll go over that.